All right, so we have a file to download today, array 1. This is actually right where we left off last time. One slight change. I had a little error, and I'll show the error that we had. And so if you followed everything, you just want to pick up with where you are, there's one change you'll have to make, but I'll point it out to you as we review the code. Otherwise, start with where I left off last time, and we'll be ready to pick up. So just to review, our chore is that we started off with this list of distances, road distances between each of these hotels. Our goal is to automatically produce a route that we can drive to be able to, go to each one of these. As it turns out, we talked about the fact that computationally it's beyond our capability to actually come up with the best route, but we're going to implement the next nearest city algorithm to be able to come up with a route, a reasonable route. One that we could drive way, way, way faster than we could calculate what the shortest route is. So, but just remember that algorithm says we're going to start somewhere. For us, we'll start in Salt Lake City because it's our closest starting point. And the algorithm says choose as your next step in the route the next closest city that you have not yet been to. And then repeat until you've gone to all the hotels. That's the algorithm. You can say it in English really easily. It's a little bit harder to write it in VBA, but it's also pretty doable. And so that's our goal, to finish that algorithm today. We're going to begin by reviewing what we have accomplished so far. Oh. All right, so let's just review what we accomplished last time we were together. So first thing to realize is we did something different with variables. We declared, for the first time, last Wednesday, we declared variables that are outside of a subprocedure. What's so special about declaring a variable at the top of a module instead of at the top of a subprocedure? Go ahead. Yeah, it's a global variable. So now all these variables, and these are arrays of variables, but all these variables I've declared out here are now accessible from any subprocedure in my code. Now, so far I only have one subprocedure, no big deal, but we're going to write at least 2 more subprocedures today that will need to be able to access those same arrays. So far all we've done is this init subprocedure, which says, all right, first we're going to have a couple of variables to control things that are going on. We're going to figure out how many arrays we have, or how many hotels we have to build the route for, and then a couple of variables just to control our loops. We started off by saying, let's find out how many hotels we've got, and what did we do? We looked at our distance sheet, and we looked at a particular cell. Which cell? Column number 1, row number 1.04 million, right? However many rows there are, we're starting at the very bottom. From there, we're going to do end up. That'll come up until we bump into some data, and then we're asking for the row. Now that's going to give us row 37 because we have, on our distance sheet, we have no value here. So we have 36 hotels. We start in the second row, so when we come up and we bump into the data this way, all the way down here, when we come bump into the data, we hit 37. But that's one more hotel than we actually have, so we're calling our hotel count that row number -1. Then we use that number to actually set the size of our arrays. When we declared them up here, we didn't say how big they were. That means they're dynamic arrays. We have to redim them before we can use them. And so we're going to redim them to hotel count. Oh, wait a minute. We already subtracted 1 off of this to get hotel count, and now we're subtracting 1 off again. What's going on? So if our hotel count is 36, why are we subtracting 1 off to dim this array to 35? Yeah, because these are 0-based arrays. They start counting at 0. So to get 36 variables in this array, we put in the top index of 35, and that will give us 0 through 35 for the number of variables that we declare. Single dimensional array for hotel as well as for route. Remember that our hotel is just the names of our hotels. Our route is just going to be the index numbers of those hotels in the order that we're going to visit them in. That's how we're going to hold the output of what we're figuring out. But then we have a distance array, which is a 2-dimensional array. So we can think of this array as having rows and columns, and the intersection of each one of these should be the distance between the 2 properties. So when I look right here between 0 and 2, that should tells me it's 374 miles from this hotel in downtown Los Angeles to this hotel in Phoenix. Anyone from Los Angeles or Phoenix and know about the distance from Phoenix to LA? Is it about 370 miles? Something like that, yeah, so that makes sense. So the numbers make sense for us, so that's great. So we've got those declared. So now we are initializing those arrays. Remember that when we declare any variable, it gets a default value. And the default value is different depending on the type. So what if I have a Boolean variable? What's the default value for Boolean? false. Default value for string, empty string. Default value for integer, 0. How about for single? 0. This is going to go quick here. How about for double? Byte, long, 0, 0, 0. If it's a number, it's 0. That's the default value. Okay, so we need something besides a bunch of blank strings in our hotel array, and so we're going to loop from 0 to 35. That'll give us all 36 elements of our array. And so hotel sub 0, the first variable in that array, we're going to look at the distance sheet, and we're going to look at row number 2 plus x. So when x is 0, that'll be row number 2. Column 1, and we are reading this value into the 0th spot of my array. So from row number 2, that's the first one. As we increment through this, we'll pick up the next ones and write those right into the array. So the next time through, hotel 1 is going to be the next cell down, hotel 2 will be the next cell down, and so forth. Now, in the route array, we are filling it up with negative 1s, because when it starts, that array is going to start with a bunch of 0s. But remember, what this route array does is it says, this is the order in which these hotels are going to. As we're trying to figure out what the next hotel we're going to go to is, we can't say just, pick any hotel to go to. It has to be the hotel that is closest to where we are, the shortest distance between the hotel where we are and the next hotel, with one other constraint. What's the constraint? Yeah, one we haven't been to yet. And the way we're going to tell if we've been to it is the index number is going to be here in the route array. So when this route array is initially full of 0s, that's going to be a problem, because we're going to say, what's the shortest distance that we haven't been to? And we're going to say, oh, we've been to 0. In fact, we've been to 0 a bunch of times, because it starts off with all 0s in it. So that would be a problem. And rather than bump into the problem and then fix it, I said, let's just fix the problem starting off by initializing that route array to have all negative 1s in it. Why negative 1? Why not negative 2? Yep. Truth is, negative 2 would work fine as well, as long as it's a number that's not one of our hotels. It could be, we only have 0 through 35 as the indexes for our hotels. We could put 36, 37, 38. Any of those would work as well. But remember, we're trying to write this so that if we increased the size of our hotels, of the grid we're working with, we wouldn't have to change too much code to accommodate that. And so we know we're not going to get indices lower than 0, so negative 1's a pretty good choice. Okay, this loop's not too hard. This loop is the one that'll make your head hurt. This is a nested loop. It is not a simple loop. And so let's just take a look at it. We have 2 control variables now because we have 2 for loops, y and x. We come to this line and we say, great, we've got a variable. We've declared it up here at the top. It's y. Dim y as an integer. We're going to start y off at 1. And if we ever get bigger than 35, we're out of this loop. Now, we immediately come here and say, all right, we're going to start x at something. What is x going to start at? Also starts at 1. It starts at whatever y is. And so, and this is the change I made, by the way. I think I put here 1 to 34 in the example before, but this needs to go all the way to 35, and we'll see here in just a minute. So if you're working on your own code, make sure you've got these indices correct here. So now I start this one off. So now y is 1, x is 1. And now I'm going to write to my dist array. So remember, dist is my 2-dimensional array. It is square, so it has the same number of rows and columns, and each of those is the same as the number of hotels. And so the first place I'm going to write to is row number, in my array, row number 0, because y starts at 1, column number 1. So that means, if I think of this as the array, and remember, this is just a visual representation of the array happens in memory, you can't see it. So this is the first place I'm going to write. Why don't I write to here first? Why not write to 0, 0 first? Well, it's itself, that's true, but there needs to be a value here. What value should be here? Yeah, should be 0. What kind of variables are in this array? Yeah, these are integers. This is an array of integers. And so because those are numbers, what value is already here? Yeah, 0 is already there. There's no reason to write to that because it's already 0. And so this is the first one that we're writing to. So row number in my array, row number 0, column number 1. Now, where am I pulling that value on? I'm looking at my distance sheet. I'm looking at cells 1 plus 1. So this should be, this should be 2 and 1 plus 2. So row number 2, column number 3. Let's go back and look at that distance sheet. Row number 2, column number 3. Yeah, sure enough, that's where that number's coming from. So that looks pretty good. So we read that 691 in here, and then we write it into the corresponding spot in the array. Now the second thing we do here is a little bit wonderful. We are writing exactly the same value to a different spot in the array. And what's so special about what we've done with these indices here? Yeah, we've just swapped them. So when we write to row number 0, column number 1, we also are going to write row number 0, column number 1. We're also going to write to row number 1, column number 0. And so that's going to put the mirror image of these distances over here. And the whole point is so that when we're looking at hotel number 2, all I have to do is think about this row, and I have access to all of the distances between hotel number 2 and all the rest of the hotels. So when it comes time for me to say I'm now at hotel number 2, what's my next nearest hotel? I just have one dimension to look across. I don't have to think about, well, is it row, column, where do I have to look? Just one little dimension. That's going to make our lives a little bit easier. And it's really not using up any more memory to store those variables because these variables are already declared, or to store those values. These variables are already declared. They're already using memory. All we're doing is we're putting something besides 0 in there. Ooh, I think I dragged that by mistake. Cancel. Okay. So that is going to get us, so that gets our first number put in there. We then hit this next. And what does this next do? So at this point, we've got the 691 written to the right part of the array. All the rest of my distance array is full of zeros. I've got one number in there so far. I hit the next, and next does, yeah, in fact, it even lets me put the x in here and the y in here. It's not even a comment, it's valid syntax. This gives me the next x, and so it makes x go from 1 to 2. Yeah, it adds 1 to it. And then I go back to this loop. What happens to y at this point? How does y change at this point? Yeah, y doesn't change at all. Y won't change until we hit here. We've got to finish the inner loop before we hit this y. So y is going to stay at 1, and we're going to take x to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way up to 35. And then that will put that whole first row into my data. Once I've done with that, in fact, so when x is 35, we're going to run these lines with x equal to 35. We hit the next x, and that makes x what? 36. It actually goes out of bounds. It's the fact that it went out of bounds that gets me out of the loop. So it's going to go to 36, and it's going to go, wait a minute. That's no good. And so it'll drop out of the loop. It'll hit y, and so that'll be the next y. So y was 1 for that whole first iteration of the x loop. Now y is going to go to 2. What's x? At this point, x is? No. X is 36. Right here, I just incremented y. X is still 36. I'm coming back up to the top of here, loop, and because y is not out of bounds. And so now we're starting this loop again. And here we say now x is going to get a new value here. What value will it get? Yeah, now it gets whatever y is. Y is now 2. X is going to start at 2. And each time we come back through this loop again, x is going to start 1 higher each time. That's because the data that we're pulling off starts 1 column over more each time. And then the next time through the loop, we'll go all the way across. We'll increment y, which will put us down a row. And then we'll go all the way across. And that'll fill up that whole array. And we've got a stop here, which we don't need. And this print we don't need here anymore. That was, must be editing a cell. Escape. And volume down. And so this loop here is just printing off our distances. I'm going to get rid of that and get rid of the stop as well. So that's just kind of rebooting us to where we left off last time. Okay, so just hold your fingers up, scale of 1 to 5. How many of you are saying, yeah, I think I told you, even with the nested loop, I'm feeling good. I'm seeing a 4, some 5s, 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 5s. I've got a 3 over there. And if you're feeling 3, 4, 5 right now, that's a pretty good place to be. Hopefully by the end of this, we won't have moved you down any. You'll be at the same level or going up, or hopefully moved up a little bit, except to 5s. If you don't, that'll put you back down to 0 or something. Don't do that. So, okay. So now we've got to implement the algorithm. Next nearest city algorithm. Someone tell me the algorithm in English. Just explain to me what we have to do in English. A whole algorithm to calculate our whole route. It's a really simple algorithm. Did I already say it? I don't think I said it in class yet today. We talked about it last time, but. So it's the next nearest hotel algorithm, or the next nearest city algorithm. What's that? Oh, I'll get you started off. Step 1, go to Salt Lake City. That's step 1. Now the rest of the steps are all the same. So what's the next step? Yeah, find the closest hotel that we haven't been to. Yeah, and then do that over and over again until you fill the whole out. That's it. So at the hotel where you are, figure out the closest one you haven't been to. That's the next stop. Yeah, it's a pretty short algorithm. You say it in like half a sentence. It's like a dependent clause, and then just do that until you've been to all the hotels. All right, so that is our job. So we're going to make another sub-procedure. I'm going to make another sub-procedure here called calc route. Sub-calc route. And the first thing calc route is going to do is it's going to get our hotels, all of our arrays populated. So I'm just going to start off by saying init, I-N-I-T. So this says fill the arrays. So when we say calc route, we better make sure our hotels, our arrays are all populated, and then we should be ready to move on. Now, step 1 of our algorithm was the part I said, start at Salt Lake. Okay, how do we say, and we come back here and look at the visual representation of our arrays, how do we say start in Salt Lake City? Well, we've got 3 arrays here that we're manipulating to solve this problem. How do we say start in Salt Lake City? In the arrays. Let's narrow it down. Which array am I going to work with? The route array. And what do I do? Yeah, route sub 0, so the number 0 variable in the array equals, I can't write Salt Lake City here because it's an integer array. 1. Yeah, I'm a little bit sad that Salt Lake City in this actually ended up as hotel number 1, because it's not 1 because it's first, it's in the first slot of this array because it's first. The 1 in this case only means Salt Lake City, right? It is the index number of Salt Lake City. And so we have now said start at Salt Lake City. Where are we going after that? -1. We don't know yet, right? It's not a valid hotel. And so that's what we've done so far. Start in Salt Lake City, simple. Route sub 0 equals 1. All right, so now route sub 1, our next stop in our route, is going to equal 7. Now I know it's 7 because I just solved the problem an hour ago. So I remember that it's 7. But we don't have the luxury of just dropping the 7 in there. We've got to tell VBA to figure out the 7. So instead of just putting a 7 there, I'm going to say this is going to equal next hotel. I got to make the function. That's not built into VBA, in case you're wondering. It's a function I have to write. So next hotel, and there's a couple of ways. We could have the next hotel algorithm figure out which hotel we're working on. Right? Because the array's got a bunch of -1s in it. We could just start at the bottom, come up until we hit something besides -1, and we could say that's where we are. But just so we can get a little more practice passing values to parameters, we're going to tell it which hotel we're on. So next hotel, and I'm going to say where we currently at. We're currently at hotel number 1. So we still have some work to do here to get this kind of fully generalized. But for right now, we're going to call the next hotel procedure, and we're going to tell it we're currently at Salt Lake City. Okay, so let's go ahead and write the next hotel procedure. I'm going to write it here. I could go above or below, it doesn't really matter. I'm going to write it below. So this one is not a sub-procedure, but it's a function procedure. Why are we making a function procedure? Because this code's going to send us back a number. We say, hey, what's the next hotel? If we're at hotel number 1, what's the next hotel? And it's going to give us back a 7. 7. Only reason I know it's 7 is because I remember it's 7. But it's going to give us back the index number of the next nearest hotel that we haven't been to. Okay, so because it's a function, we've got to set up a return value. So what data type should this function return? Integer, yeah. integer. So it needs to be an integer. whoops, should we say as integer there? Why integer? Because it's going to be putting a value into the route array, and that's the kind of variables that are in the route array. We're going to put an integer, we're going to receive an integer variable. Let's actually have it send back an integer variable. What would happen if we sent back a byte instead of an integer? VBA would do the conversion for us. It would say, oh, make it into an integer. I can do that conversion. But we might as well use the data type that's the right one. There's got to be some data type. Might as well be the right one. Okay. Now, remember, when we call this next hotel, we are sending it the hotel we're currently at. And so we need to make a provision to receive that value. So I'm going to call this current hotel also as an integer. Okay, so I'm sending, the first time through, I'm sending this down a 1. So current hotel is going to be 1. And so as I look at this distance array, out of all this array, and remember it's fully qualified now, all these numbers are filled in. But as I look at this array, how much of this array is relevant to me in this step, in solving this step? About what percentage of this array is useful to me? 3%? Oh yeah, you're right. It's about 3%. That's good. You actually did the math. Good for you. I was going to think of it more as a fractional percent, about 1/36th, which is about 3%. That's good. So right, because out of all these rows, they are all irrelevant except for this row, right? Because this is the one that shows the distances from Salt Lake City to every other hotel. It may be closer to 6%. Because this column has exactly the same data. And so that's relevant as well. So yeah, it's 2/36, which is kind of close to 6%, I guess. All right, so just as I begin this algorithm, I'm going to start just by being sure that I have control over the set of numbers I have to work with. And so let's just write a loop that will loop through and print off all the numbers that I have to consider. So let me dim x as an integer. For x equals 0, to what? When we were doing this, when we were initializing the arrays, we hard-coded the top number here. We probably would have been better off doing what? Instead of having a 35, we probably should have put hotel count, O-U-N-T, -1. So hotel count is 36, so it should be 35. Why did we put 35 there? It was just because it's a lot to bite off to start off and have it be even more abstract, so we had the numbers in there. Everywhere we have a 35, we could change to hotel count -1, and that would work, for here. Maybe I will. It's only a couple more places. Oops. But if I try to refer to hotel count now in my other sub-procedure, what's the problem? What if up here in next hotel, I tried to refer to hotel count? Yeah, this thing is declared inside of this sub-procedure. It's only accessible from inside of this sub-procedure. So I cannot just refer to hotel count. What are my options? I could make it global, well, technically a module level variable. I could put it at the top of this module. And that would be okay. I like to avoid module level variables when I can, just because the more module level variables you have, especially if you get a lot of them, it's easy to kind of accidentally change one without realizing what you're doing. So, but as it turns out, there's a function just built into VBA that will let me ask the upper boundary of an array. And so I've got my, all my arrays are the same size, so I can choose any of them. I could say route to the upper boundary, U bound, of the route away, or O-U-T-E. And so this will just, what's the upper boundary? 35. That'll just give me 35. I could use hotel here just as well. Or I could do, I'm going to be looking at the distance array. I could put distance here, dist, but because dist is a two-dimensional array, I have to tell it which dimension I want to know the upper boundary of. And so it takes 2 arguments if I have a multi-dimensional array. But any of those will work. I could ask for the upper boundary of the first, the second dimension of the distance array, the upper boundary of the hotel array, or the route array, because those are all going to be 35 in this problem. And I'll go ahead and put my next in here. And I just want to print off debug.print. I'll print x, so that'll give me my index, and then I want to print the distance. So distance, sub, which row am I interested in? Row number 1, we'll make that more general here in just a minute, and column number x. And so I should print 0, and then I want to see that number right there, 691. Then I want to print 1, so I'm in column 1 now, and that should be 0. 2 should give me 653. 3, 662. I want to see that I'm iterating across that part of my array, and I've got that vector of numbers. Because if I've got a loop that's printing off that set of numbers, then I got, great, that's the set of numbers I got to find the smallest number in. Not too bad. So it's always a good idea when you're kind of working with this to say, all right, let me just see, do I have access to the set of numbers I think I have access to? Because that'll be very comfortable if we've gotten that part down. So that's pretty good. Oh, let's go ahead and set up the return value of this function. How do we set this function's return value? By setting the name of the function equal to something. Now, I'm just going to set it equal to 7 right now. I know that's what it's going to return when we press 1. Ultimately, we have to calculate that 7, but that will give us the value that it returns. So we've got this fairly well specified. We still have some logic to add to it, but we should at least see these results come off. So if I run calc route, it's going to call next hotel, and next hotel is going to have this loop in it. I should be able to see that go. So got my immediate window open. I'm going to run calc route, and that has given me a bunch of distances, and it looks good. 0 is 691, 1 is 0, so distance between Los Angeles and Salt Lake City, almost 700 miles. Is that right? Yes, that's about right. Distance between Salt Lake City and Salt Lake City is 0 miles. Distance between Salt Lake City and whatever number 2 is. What's 2? 2 is Phoenix. So the distance between Salt Lake and Phoenix is about 653. I guess that sounds about right. Anyone from Phoenix? No distance? Do you drive that? No? Okay. Let's trust the numbers then. So it looks like we've got the right numbers kind of spooling off. I may just check the very last one. So 841 should be the last number in this vector. 841, there it is. So that looks good. I feel good about that. Like now my next hotel, I've got access to the right set of numbers. Now I just have to figure out which one of them is the smallest. Subject to being one that we haven't been to yet, but let's just start off by picking the smallest number. All right, so how are we going to tell it to pick the smallest number? And in fact, it's not just, we don't just need the smallest number, we need to know where the smallest number is. Now, unfortunately, you folks come to me from experience with Excel. And in Excel, you've got a crutch called min. Yeah, there's a min function. Just Excel, tell me the smallest number. What's the smallest number? We don't have anything like that in VBA. Well, we could actually call the min function. Because as it turns out, almost any time when you can pass like a range that has numbers in it, in VBA, when you're calling that function, you could pass an array to it in place of the range, and it'll just work on this. It'll work on the array like it's a range. But unfortunately, our array isn't just an array, it's just one dimension of a big array, so it would be quite a lot of work to be able to get the min to do the trick we need it to do. Plus, it doesn't tell us where it is. It tells us what the smallest number is. And then you could use match to find out where that smallest number shows up. So you could do it, but let's just do it in VBA. So here's what I'm going to need. I'm going to need a couple of variables. Oops, next hotel. So I'm going to need something that tells me what's the smallest distance, the shortest distance I've seen so far. So let me dim one called short distance. We'll do that as an integer. And let me also dim one as the short index. INDEX. Also as an integer. We have to know not only what's the smallest distance that we've seen as we're looking through this list of numbers, we also have to know where did we see the smallest number. Okay, so that looks pretty good. So now I've got my, I did mean short index. What did I put? Shote? S-H-O-R-T. Short index, thank you. All right, so now I'm looping through all of these values, right? At this point, I've got access to, serially, I have access to each value one at a time. So here's what I'm going to do. I'm going to say if the distance that I'm currently looking at if that is less than the shortest distance I've seen so far, short distance, then I got a new contender. This could be the shortest distance. We'll decide what to do there. Well, in fact, once we've found a new possible shortest distance, we've got to record two things. What are they? Yeah, we've got to remember, where do we see it? This could be the shortest one we've seen. This could be it. It's the shortest one we've seen so far, and it could be the last one. And so let's go ahead and record where we saw it. Short index equals what? This should be the hotel number that corresponds to that short distance. So how do what is that? Yeah, it's X, right? Because as I'm going through, as X is changing, it's looking at each different hotel one at a time. And so X is just the hotel number that I'm currently looking at. And we then need to say, aha, this is our new shortest distance that we've seen. So now our short distance is equal to that short distance that we saw, which is dist that one that we looked at, the one that was the contender. Okay, so let's just kind of think through this. We've passed in a 1 for our current hotel. Oh. Yeah. There was one more thing that I wanted to do here. I don't want to leave this hard-coded. That's the problem. I thought this code looked a little bit simple. This says we're always looking at row number 1. I don't always want to look at row number 1. What row do I want to look at? Whichever one is the relevant one. And how do we know the relevant one? It's that when I call next hotel, I send a value down to the parameter. So current hotel is going to be 1 the first time through here. So anytime we're referring to that distance array, it should be current hotel rather than just the 1. That way, when I send a 1, it's looking at number 1. When I send a 7, it's looking at row number 7, and so forth. Should have got that before I duplicated it. Sorry about that. Up here, yeah, so this is actually saying the upper boundary of the distance array and the first dimension. Yeah, this might actually be a little bit cleaner. I don't know. We're actually looking at the distance array, so it makes sense to look at the distance array, but we could just ask for the upper boundary of the hotel array. That way it's only one argument. A hotel array is the same, it's one dimension, but it's the same size as each dimension of the other one. Okay, let's just kind of think through this now. We've passed in a 1. And so we're going to come in here for x equals 0 to the upper boundary. So now x is 0. So we're printing at first x is 0. We're printing the distance, 691. If our distance, 691, that's what that will be, is less than, what's our current short distance? At this point in our code, what is the short distance? Yeah, it's 0. It's its default value. And its short distance is an integer, so it's going to be 0. By the way, are we going to find any distance that's less than 0? No, so we're in trouble here already. So we better start off by putting something else in that short distance. What should we put here? Before we start looping through, let's put a value in here. Any thoughts? 1,250. Short distance equals 1,200. Why 1,250? This would work, by the way. This is a fine number. Above it. Yeah, all of the distances inside that distance array are less than 1,250. In fact, the largest ones, I don't know, but I think it's less than this. I don't think we have any other. Oh, we got some fits. So this wouldn't work. No good. There's one that's like 1,500 miles. It was like Seattle to Phoenix or something. I don't know. But the point is, we want this to be some number that's bigger than any number we've seen inside of our distance array. I think there's a couple of ways to get there without actually having to look at the data. One is to say, you know what? Let's just put in the biggest number this integer could possibly be, 32,768. Whoop! 32,768. Now, you probably didn't actually memorize that number, and it took me a long time to memorize it, years, maybe decades before I really memorized that number. Oh, it's wrong anyway. That's the lower boundary. Negative is the lower, it's 67. There can't be, I don't care what's in the array, there can't be a value bigger than that. So that's actually a pretty good choice. But I have one choice I like even better. 24,000. Why 24,000? It's the circumference of the Earth. Listen, if you're picking a distance, and the distance between these two hotels is further than driving all the way around the world, something's gone wrong. And so, there's kind of a logical reason for why this is a good one, a logical reason for why, the maximum number. If we know we're in the United States, how far is it across the United States? You could say, 3,000 miles is also a pretty good choice. I'm going to go 24,000 miles. Okay. So now, whatever we first bump into, we're going to find a distance in our array that is shorter than our shortest distance. So no matter what, the first time we get to look at a number, we're going to say, aha, that's our new possible shortest distance. So as we're going through this now, when x is 0 and our distance in the array at x is 691, is that what it was? No, I forgot. Yeah, 691. So the distance is 691. That's less than our shortest distance. It's way less than 24,000 miles. And so we're going to say, great, now our short index is, which hotel did we see this distance for? It's 0. It's what x currently is. It's Los Angeles. That's 0. And our shortest distance now is that 691 miles. Great. And so now where's our next? So now we hit this next. We go back up here. X now becomes 1. By the way, what's at the distance array at current hotel 1, x1, at 1, 1, what's there? Anytime the row and the column index is the same, what's in the array at that location? 0. It's not nothing. There's something there. It's 0. It actually looks like nothing here just because I didn't write the zeros in, but we could write them in. And remember, this is a numeric array, and so it can't be empty. It has to have a number value in it. And so it'll all be zeros. And so I'm looking now at this, row 1, column 1 here, and that's 0. And so now is the current distance 0 less than my short distance, 691? Yeah, that's less. And so this we're gonna store x as our shortest index, and we've picked up now our shortest distance to be 0. Now, we really don't want this to happen. We've got to avoid this from happening, but we kind of see how the mechanism works. As we then go through, we wouldn't ever find another number that's less than 0, and so our short index would be the smallest index we saw. That's the value that we want to return. So instead of returning 7, we're going to return the short index. So that's pretty good. So at this point, it should return 1, right? It's going to return the index of where it found the 0. We don't want it to return it, but the way we have it coded right now. So I'm going to put a stop here in my calc route. And let's just make sure that is returning 1. So I'm going to run this, and let's just see what is in route sub 1. And it should be the hotel number for Salt Lake City, which is also 1. So it's doing what we've calculated to do, but we still have one more step to put in here. Okay, stop my code. So what's the next step? We got to ignore any place that we've already been to. So, and the truth is, we could do that. We could make that check either after we have found the next new contender, or we can make it before. We can either say, first find out if it's a city we haven't been to, and then find out if it's smaller than our contender. Or we could say, first find out the number is smaller than our contender, and then see if the city if we've been to. Either way, the order doesn't matter. We can go either way. I'm going to write it on the out. I'm going to write this other condition on the outside of this existing one. So I'm going to put another if statement in here. I'm going to say if. In fact, let me just go ahead and get my syntax in, and then I'll put in the condition. I'll write a whole new if statement around this one. Tab that one in a bit so I can see it. And now I got to do something here that figures out, is this one we're supposed to have? There's a great function for this. It's called been there. And I just pass it the hotel number I'm interested in. So I just have to say been there, X. Oh, I say that there's a great function, but we haven't written that function yet. We still have to write that. So we're going to be calling a function that we have to write. We're going to send it to whichever hotel number we're currently looking at, and it's going to tell us if we've been there or not. So let's go write this function. Oh, another function. It's like function happy today. Function. So function, been there. We're going to send it a hotel number. Hotel ID. Hotel number. As an integer, what data type should this function return? What do you think? Yeah, Boolean. It's just going to return true or false if we've been there or not. Is this a hotel we've been to? So we'll do this as Boolean. Oh, I've got to write one more loop that loops from 0 to 35. Oh, okay, I'm getting good at it though. For x equals 0 to the upper boundary of our route array. Okay, now how do we know? So we're now looking through the whole, we're set up to look through the whole route. How do we know if it's a hotel that we've been to? If something, then we'll do something. Okay, so now we're going to be going through that route array one at a time, looking at route number 0, looking at route number 1, route number 2, route number 3. How will we know if it's a place we've been to? Let's take a look right here. How can we tell we've been to Salt Lake already? Yeah, if the value of the variable at the current index of my route is equal to the one I passed in, we've been there. So I've passed a hotel number in, so I'm just going to say if that number is equal to the current position in my route array, route sub x, then we found it. So what do we say? Yeah, we got to set the return value of the function. Been there equals true. If we go through this whole loop and we never find where the route number is equal to the hotel number we passed in, it will never say been there equals true. So what will been there return? Yeah, it will return its default value. Booleans are false by default. So if I never say it's going to be true, it's going to return false. Yeah? What did I do? Oh, I haven't declared the x variable yet. Thank you. Dim x as an integer. Okay. Now, one more little thing that we're going to do here. Once I've found this, once I've said been there is true, is there any reason for me to keep looking through the rest of that array? I don't think I'm going to find it. And even if I did, what would I say? It's really true? It's twice as true? It's double true compared to what it was before? It's either true or false. I mean, even if I did find it again, it couldn't make it any more true than it is. And so there's no reason to keep looking here, so I'm just going to say exit 4. I could say exit function, but because I've got nothing between the end of my function and the end of my, between the end of the loop and the end of the function, exit 4 or exit function will do the same thing here. We're done. No reason to keep looking. I'm going to save myself a couple of nanoseconds. Okay, I mean, it's not having that exit 4 is not a big deal. It'll work just fine without it. But logically, there's no reason to keep looking. No, that's not too bad. Oh. So now, been there returns true if the number I pass to it is in the array, in my route array. So now I I only want to consider this as a possibility in my next total if bin there equals false. So if my bin there function returns false, in other words, I didn't find the value in the array, that means I haven't been there. This is now a possible one. Check to see if it's shorter than my current short distance. I think that's going to bring back the 7. Now let's go ahead and I'm going to run my main one again, my calc route, and we're going to see if it brings back the 7. So route sub 1 equals 7. Route sub 0 should, so route sub 0 is 1, starting in Salt Lake. Next part of the route sub 1, is go to Las Vegas. That's pretty good. Let me look at one more option that I could do when I'm calling that bin there function. I know from asking students this many times over the many years, it's a little easier to think of when I say if bin there returns false, if bin there equals false. But what I have here, it will be just when this is false, then I'll have false equals false, which is true. When this is true, I'll have true equals false, which is false. And so it really just needs to be the opposite of whatever is here. And so the other way to say this is if what? Yeah, if not bin there. Those are logically identical to each other. I like this one better because it reads a little bit better. If not bin there, if I haven't been there, then check to see if it's the short distance. But you can leave it either way because they are logically equivalent to each other. Okay, let's just go ahead and kind of hand code in the next one here. Okay, so now I'm going to say route number 2 is going to equal, where would we be at hotel number 7? I'm going to run this, and we'll see what that produces. So now I'm looking at route number 2, and it's got 12. Put the next one in. Route number 3 is going to equal wherever we were when we started hotel number 12. Okay. I'll go ahead and run that. Should be able to see what route number 3 is. I'm not mistaken, it's number 19. Oops, route number 3. You stop that and run it again. Look at route number 3. And that gives us number 19. I've got a debug.print somewhere that's causing me a little bit of grief. Let me get rid of this now. Okay, so of course we're not going to actually write this out all the way to 36 one at a time. We could, it would be a little bit of effort. But what I'm really after here now is I'm going to try to make a loop that can produce, that can kind of turn these lines into something I can put into a loop. This looks pretty good. Now, up here where I'm initializing, that'll be outside of the loop. But now I'm going to say, yeah, this is not too bad. Route 1, 2, 3. I can definitely make a loop that can control that variable. Oh, but this looks difficult. 1, 12, or 1, 7, 12. In fact, we know the next one is 19. So how am I going to do that? How can I possibly make this into a loop? Any thoughts? You said that as if it was so easy, but this requires a little bit of thinking here. So in fact, I need something. This is going to return the 7, right? This one is going to return the 12. I just need to do something to capture what comes back from my next hotel. So when I call next hotel and I give it a 1, I got to catch that because that's going to give me the 7, and then I can put that right here. We see it? This sends back a 7, I need that to be here. This one will send back a 12, I need that to go here. Well, there's good news. I am catching it right here. So the 7 that this sends back gets put right here. So let me just go ahead and put that route sub 1 there. And by the way, that means that route sub 0 is going to go here. And this is going to be route sub 2. This will be route sub 3. Oh, so now this looks like an easy loop to write. Because now I just have to get some number that goes 1, 2, 3, 4, another vector that goes 0, 1, 2, 3, and we're set. You got 4 minutes. See if you can do it. Give me a loop that will fill up that whole. And by the way, that's it. That's really the end of the project, of this problem. We'll want to print it out. We'll do that together, but I'm going to give you 4 minutes to build a loop that will do that as a loop. We get a 4-minute timer. Oh, yeah, that's a really good idea. Pause the recording. Okay, so we've got to run these vectors 1, 2, 3, 4, 0, 1, 2, 3, and so I do not need to write to route sub 0 because route sub 0 I'm hard coding. I'm saying start in Salt Lake, and then from there calculate everything else. And so we're just going to go from 1 to the top of our route. I call this hotel, upper boundary of hotel. Probably makes more sense to say upper boundary of route here because I'm going through the route, but they're the same number. They're going to be 35 either way. So now route sub 1, the first time through, is going to be next hotel, but pass it route sub 0. And so that'll give me route sub 1, route sub 0, and so forth. So that should do it. Let me go ahead and delete this code, stop and start my code over. I deleted a little too much. So let's get the next back in there. So now there's route sub 3. I should be able to look at route sub 4. I got 20. I'm going to go ahead and just make another loop that prints out the whole route. For x equals 0 to the upper boundary. Why did I put the 0 and the O right next to each other? I don't know. Debug.print. I'm going to print my x, my hotel number, and then I'm going to print the name of the hotel. Oh, so how do I get to the name of the hotel? Oh, so this is going to be, that's the number here. Why don't we actually make that as x plus 1? That will be like the step in the route. And then I'll put the hotel number, which is route sub x. And then I want the hotel name. Where do I have all my hotel names? In my hotel array. And I'm just going to put the hotel number, which is in the xth position of my route. So if I think of that route array being filled with 7, 12, 19, and so forth, then when I print x, and then I print route sub x, that'll print the 1. And if I take that 1 over here to hotel, that will print Salt Lake City. So route sub x is the 1. So hotel sub route sub x is the name of the hotel at that location in the route. So let's just go ahead and see what route it produced. So we start in Salt Lake City. Then we go to Las Vegas. That looks pretty good. From Las Vegas, we go to Fairplex. That doesn't really tell me really where it is, but I guess it's somewhere near Anaheim because that's the next one. And the next one is right there, also in Anaheim. That looks pretty good. Cerritos, that seems like it's in the Los Angeles area, so that's probably pretty good. Long Beach, again, LA area. LA, I think, is in the LA area, so that's pretty good. Beverly Hills, it's pretty good. We're like in the San Joaquin Valley. We're doing great. The Los Angeles downtown, I'm not so sure that's the best way to go around town, but it's looking pretty good. Monarch Beach, you don't know where Monarch Beach is? Maybe it's somewhere south of Los Angeles because the next one's in La Jolla, and I grew up in San Diego. I know La Jolla, that's San Diego. San Diego, San Diego, San Diego. So this looks pretty good. This isn't too bad, right? So we came down to Las Vegas. We went over to Los Angeles. We're going down to San Diego. So far, pretty good. Ooh, now Palm Springs. Where's Palm Springs? Yeah, it's a little bit inland and a little north. It's a little north of Los Angeles. So now we came down from like Las Vegas. I'm looking at this from my perspective. We came down from Las Vegas into Los Angeles, went down to San Diego, and now we probably came right back through Los Angeles on our way up to Palm Springs. What's after that? Bakersfield, that's Central California. That looks pretty good. Now San Jose, we're Northern California, so probably wasn't optimal, but still not too bad. Silicon Valley, that's Northern California. I don't know where Pleasanton is. I guess it's Northern California. San Francisco Bay Bridge, San Francisco. The Westin, St. Francis, I don't know where that one is. This is really funny. I'm not sure how this name got in here. It's really not in Montreal. I mean, I think it really is in Montreal, but the address is in San Francisco. San Francisco, San Francisco, San Francisco. San Rafael, that sounds like it's up there. All those places named after some kind of Spanish saints or Catholic saints. Sacramento, definitely up there. Oh, now we're even further north, Pacific Northwest, Seattle. Uh-oh. Scottsdale. Scottsdale? Where's Scottsdale? That's Phoenix. So we went down to Las Vegas. We're pretty close to Phoenix. Well, yeah, we'll get back there maybe sometime. Why did we go to Los Angeles instead of going to Phoenix? Because Los Angeles is marginally closer than Phoenix. They're really very close to each other. The distance is very similar. And so, yeah, that was the closer one, and that took us all the way up here, and it leaves this orphan of a whole cluster down here in Arizona, which ultimately we have to come back to at the end. So at the one hand, we should feel pretty good that we produced the route. We followed the next nearest city algorithm, and there's a lot to like about this algorithm. The part that should be a little dissatisfying is that you could have done better with what? Yeah, a pencil, and plotted these on a map and a pencil. You could have done better. So why did we do it this way? Well, you could do better with a pencil and paper if you have to do it once. But what if you have to do it 100,000 times a day? Yeah, you can't do it. You can't do it better that way. And by the way, this is a really simple algorithm, maybe the simplest reasonable algorithm, and it wasn't too bad to implement in VBA. But the main reason we did it this way is that we're not really trying to figure out the route, we're trying to figure out arrays. And we had some pretty good experience with arrays working through this. Okay, questions? You now have everything that you need to do the next project. Holy cow, the next project? We got a project due when? Wednesday. I looked at the schedule, and the next project was due the following Monday. That was too close, so I pushed it back till the next Wednesday. So you've got a project due Wednesday, you've got the next project due a week from Wednesday, and it's using arrays, folks. This is the project. I'm going to have you play this game. Are you familiar? Who's familiar with this game? Big Boggle? Oh, like less than half of you. So here's how it goes. You randomize both the position of the cubes and which face is being shown. And then, it's like not a crossword. Maybe it is a crossword. It's like a crossword puzzle game. So they got to, minimum words have to be 4 letters long. So let's see if I can find one word in here. Bile, B-I-L-E. So as long as they're directly touching, you can spell the word. You can't use the same letter twice. Belt, B-E-L-T. Pine, P-I-N-E. So that's the way it plays. You are going to make this game in Excel. I have given you the definition of the cubes. Each cube has 6 sides, so they most have 6 letters, except one has 7 letters. The QU is kind of built into it. You can assume that the Q is on the U. You don't have to do the QU. The instructions tell you about that. So I've given you the definition of the real cubes. You have to choose a random position and show a random face. So as it turns out, this is really pretty similar. It's like you've got 25 hotels here, and you've got to put these 25 hotels into a route. And each time you pick another hotel, What is it? What's the algorithm? Just pick a random one that we haven't used yet. And so what we've done here is going to be pretty good, but it's different enough that it'll require a little bit of thought. There's a question in the back? Oh, yeah. So there's kind of two things that some students that have way too much time on their hands tend to do. And one is they'll make it so you actually type the words in and it will tell you if it's a real word. That's not too tough because there's like a dictionary object built into Excel. You can just say, hey, is this a word or not? So that's pretty good. The second one is actually have the computer figure out all the possible words. Also, not that much code involved, but it requires some thought to really get that one going. But yeah, those are both kind of simple extensions of this. Yeah. This one is due a week from Wednesday. A week from the day after tomorrow, so it's due in 9 days. The other project, which hopefully you've had some time to think about, is due Wednesday. Yeah, the ISBN validator is due Wednesday. All right, folks, thanks for coming. Class dismissed. And we're also